So yeah, if you don't want to be recorded, you could always just type in the text box and your name won't come up. But so this is lab number 20. It says here Earth Science Regions, Orbit and Phases of the Moon Lab. Miss G, would you like to start us off?
Sure. All right, so this is lab number 20, our moon phases lab. Introduction says here the moon revolves around the Earth once every month. That's where the word month comes from. Once every month, sorry. That's where the word month comes from, which is during the 29.5-day moon, the moon, as viewed from the Earth, goes through a cycle of phases or shapes. Sometimes we only see a little of the right side of the moon lit up. Other times it's the left side. Sometimes we see the moon during the morning or afternoon, sometimes at night, and sometimes not at all. Careful observations reveal that these motions and phases of the moon are predictable and quite easily understood. So, in this lab, we'll discover for ourselves the pattern or phases that the moon goes through.
All right, so if you take a look here, they gave you a few examples. So this is all old material. We learned this earlier in the week. When less than half of the moon is illuminated, we call that crescent. Sometimes it's the right hand, sometimes it's the left. Now, just a little bit of review. Is this waxing or waning? Is this a waxing or waning crescent?
Waxing?
So this is actually waning. Now, why is it waning? Because it's light on the left. Remember, the light always starts on the right and it moves to the left. So this is kind of like it's dying off. The darkness is taking over the moon, right? So we have a waning crescent. Our next phase would end up being a new moon. This next one here is a gibbous. How do I know it's a gibbous? Well, I could fit a big old letter, capital letter G in it. So if you weren't sure what I was referring to last week with that, there's the letter G that you could easily fit in there. So now I know that is a gibbous. And for this one, it would be the letter C for a crescent. All right, now maybe that letter C doesn't fit perfectly, but you get the idea. It looks like a letter C, where this one, you can fit the letter G in. Is this one waxing or waning? This one is also waning. So this would be a waning gibbous. And you don't have to do the labeling for here. I'm just doing it to really send a point home. Next one, we have a half moon. We really call them a quarter moon, and the reason why is because only a quarter of the moon is visible, lit, or dark, however you want to look at it. So in this case, it's this first quarter or second quarter, also known as last quarter. In this case, it is last quarter, also known as second quarter. Now, why is it not first quarter? Because it's dark on the right. If it was light on the right, it would be first quarter. Remember, all the light moves from right to left. We have the full moon, which is easy, and then we have the new moon. Okay, so next up, the diagram on the next page is a polar view of the Earth-Moon system. It is a view from above the North Pole of the Earth. The moon is drawn in 8 positions in its orbit around the Earth. The moons drawn next to each of the the moons drawn next to each of the 8 moons will be used to diagram what the moon looks like in that position when viewed from Earth. Follow your instructor's discussion and use the diagram below to learn how to determine the appearance. Okay, so you really got to put yourself in the position of somebody that's on this planet. So here's Earth, here's the North Pole, so it's top-down view. Now, if you're standing here and you look up at the moon, you'll see that most of it is dark on the left and a little sliver is lit on the right. I don't know if you can see, but that line that's running right across, that's line A. That separates what is visible to you, the observer, over here, to what is not visible. So ignore everything past that line. Only the stuff below the line, closer to the planet, is what's visible. So in this case, it would be mostly dark with a sliver of light on the right. Now on the next page, we have another one of these charts, and I'm going to grab one of these moons that seems to make the most sense. We said it was mostly dark on the left with a sliver of light on the right. So that would be this guy. So I'm going to hold down Control, tap the C button, and I'm going to bring a copy of him over here. Now you don't have to do this. I'm just doing it to demonstrate the process, how I'm doing it. But that's what it should look like. Mostly dark on the left with a sliver of light on the right. Now that brings us to this next page here where we again have a top-down view. You can see these sight lines, and you can see that diagonal line going across the moon will show what the observer can view. Now before we even get to any of that, let's try and put down some times for the Earth. What time is it when it's right in the middle of the daytime side? Someone call out. What time is it right in the middle of the daytime side? What time is midday?
12.
If that's too hard, what time is midnight?
12.
12 o'clock midnight. So then opposite that would be 12 o'clock
12 p.m.
noon. Very good. All right. Now what's halfway between 12 midnight and 12 noon? Well, if you think about it, 12 hours, it takes 12 hours to go from here to here. So 6 hours would be the halfway point. So that would tell us 6 a.m. So 6 a.m. is going to be right at the terminator between morning or night and morning. Now, if that's 6 a.m., that's telling us that up here should be 6 p.m. Remember, the Earth the Earth rotates, the Earth spins. So in this case, it's going like that. So we could then pick the times that are in between. So if I know that, let's say, for example, that's 12 noon and that's 6 p.m., what should be right in between the two of those? That's a 6-hour time span. What's halfway through 6 hours?
3.
Very good. 3 p.m. So if that's 3 p.m., then that's going to mean that directly opposite 3 p.m. on the other side of the Earth would be 3 a.m. In between 6 a.m. and 12 noon, we should have 9 a.m. And then opposite 12, 9 a.m. on the Earth would be 9 p.m. So now that we have these times on here, we literally know what time it is at any given location. So if we're here, we know it's about 9 p.m. If we're here, we know it's about 3 a.m. If we're here, we know it's about 3 p.m. So at 3 p.m. on Earth, if you were to look up and see the moon directly above you, it would be mostly dark on the left with a sliver of light on the right. I think that one looks best. Sorry about the sirens. So mostly dark on the left with a sliver of light on the right. Okay. Now, let's go to the next one. If you were standing here at 6 p.m. and you looked straight up, you would see mostly dark on the, well, I would say dark on the left and light on the right, 50-50. So dark on the left, light on the right. So we're going to take this guy, and I'm just sliding him up with the keyboard keys. There you go. And let's just continue doing this. So here, if you were at 9 p.m. and you looked up, a little sliver of dark on the left with lots of light on the right. Sliver of dark on the left, lots of light on the right. If you were here at midnight and you looked straight up, you would see a completely lit moon, a full moon. If you were here at 3 a.m. and you looked straight up, now do it from this person's perspective. as they're looking up, the left-hand side of the moon would be lit and a sliver would be dark. You kind of have to turn the whole page upside down. I don't have that ability with this, but if you turned everything upside down, you'd be able to see that. From their perspective, since they're standing on the Earth, it's all lit on the left and a sliver of dark on the right. So then that would be that one. Okay. At 6 a.m., you do the same thing. You look directly up. It would be light on the left, dark on the right. Again, because we're going from this person's perspective, so that flips these. Put that right there. Just trying to cover that up, but okay. And then if you're at 9 a.m., you look up. It's a little bit of light on the left, mostly dark on the right. And then if you look up at 12 noon and you see the moon, it should be completely dark. And to zoom out a bit, this is what you should be seeing. Now, the interesting thing about it is it takes about 28 days for the moon to go through one set of cycles. So let's start picking dates. Let's pretend that this 3 p.m. one is what it is today. Now, I don't know what phase the moon is, so we're going to be making this up. But so right now, let's pretend that it is 4/19/2021, and that this is the phase when you go outside. Now, if it takes about 28 days for a complete cycle of moon phases, that's about 4 days per phase. About. It's actually a little less than that, but this will work out. So let's try and predict when it will look like this. Well, if it's 4/19, let's add 4 days. That would bring us to what? 4/23. Let's add another 4 days. That would make this day 4/27. Let's add another 4 days. This would be 5/1. Add another 4 days. 5/5. Add another 4 days, and you just keep going through. And this is how you can make predictions about what the planet is going to look like, or at least what the moon will appear to be in the night sky. That's a cool thing about science. You can make predictions. What would that be? 5/13. And by the way, this is not 100% accurate for a number of reasons. Because, what would that be? 4, that'd be 17. So the number one reason why it's not accurate is because it actually divides out to being a little bit more than 3.5 days per cycle, but we're just rounding it up to 4 days just so the math works a little bit easier. The other reason is I'm pretty sure this isn't the current moon phase. So like, you know, we're just doing it as a hypothetical. All right. So you'll notice on the next page, and I'll zoom in a bit for this one so you can see a little better. You can see the date, the shape, and the phase along with the appearance. Now, I'm not crazy about how this worksheet does it, where it says shape and phase. Most moon phases, like for example, this is first quarter, or this is waxing gibbous, there's usually 2 words involved. You know, so the first word will be under shape, and then the second word will be under phase. So let's do the first one together. The first one, and we can start off wherever we want, but we'll start with the earliest date, which is 4/19. And the shape, I believe we said that this was waxing because it's lit on the right, and it's a crescent because it's a thin little sliver. So for shape, we're going to put down waxing, and phase, crescent. Let's find an image of a waxing crescent. And we'll drop it right there. All right, I'll even do the next one for you. So the next one, we said that this was lit on the right, so this would be first quarter, and that was 4/23. So this would be first quarter. And let's find our first quarter. And we'll drop it in place. All right. Now, you're probably wondering, like, why did we spend all that time labeling the times on here? Well, that actually comes in useful for this next part right here with you have the extended questions. So you're going to want to read through this passage, but I'll do the first one with you just to get you started on these. What is the full moon doing as the sun sets? Well, the sun sets typically at what time? Right? Sets at like 6 o'clock. So if you're at that 6 o'clock point, you could see the sun setting and you could see the moon doing what? Moon coming up, the moon rising. So in this case, how would you word that? What is the full moon doing as the sun sets? The full moon is rising. And explain. The full moon and sun are opposite. That's good enough. All right. So read through the rest of these. Try to answer them to the best of your abilities. All right. You got a few more on slide number 6. But that is it. So all in all, not that complicated. Maybe a little bit tedious because you have to put these things in. But I pretty much have this set for you. But yeah, that is it.